Hello, this is Mahendra Didia. This is continuation of pre-formulation studies on suspension. In this related submodule video, we'll focus on sedimentation of solids. This information, together with physicochemical characterization, where sedimentation of solid is, and pre-formulation solution formulations, stability and compatibility, that's so important to move forward with selection of vehicle composition and formulation. Sedimentation is critical in suspension because solid will sediment. In pre-formulation lab experiments, suspending agents and viscosity modifiers used to look at the sedimentation volumes and sedimentation rate. So let's focus on sedimentation volume. Sedimentation volume measurements are used to quantitate effectiveness of excipients, and this is given by formula F equal to VU divided by V sub 0. VU is a volume of sediment, and V0 is total volume of suspension. And depending on suspension, the experiment can be performed without agitation in a graduate cylinder or by centrifugation to accelerate particle settling. When F is equal to 1, that means volume of the sediment is equal to the total volume of suspension. Solid is completely suspended. Over time, the F value will decrease as particles sediment or settle. The VU will decrease. F equal to close to 0, that means solid is completely settled or sedimented. We'll look at pre-formulation studies, different suspending agent. In this case, we'll use zinc oxide. And as you will see, sedimentation in this case is rapid. In general, sedimentation is much slower. Zinc oxide with CMC, MCC, and metal cellulose is used at different concentration. Temperature is kept constant at 26 degrees. Volume is 100. Here are the results of sedimentation volume. As time increases, VU decreases and the F value decreases, indicating particles are settling. In this case, zinc oxide alone. Zinc oxide with carboxymetal cellulose, well-known suspending agent. Zinc oxide with microcrystalline cellulose, and zinc oxide with methyl cellulose. Readings are taken and graphed in a pre-formulation. So as shown in the graph, ideal condition, there is no sedimentation. Zinc oxide by itself shows rapid sedimentation. It improves as we add CMC, methyl cellulose, shown here, and zinc oxide with MCC, shown here. This type of information is then sent to scientists to select suspending agent. Sedimentation of solids can be flocculated or deflocculated. Flocculated suspension shows rapid sedimentation. It forms loose agglomerates. Flocculated suspension, because of its loose agglomeration, is redispersible. Whereas deflocculated suspension, as shown here, settles slowly, forms hard cake, which is not easily redispersible by shaking. In pharmaceutical development, shake well label is common. As it was discussed in physiochemical properties on sedimentation in previous submodule, flocculated systems is acceptable in pharmaceutical products. In cosmetic formulation, deflocculated are preferred. So how does flocculant work? So we can shake the mix using appropriate vessels, and the particles now settling rapidly. Again, this is shown for demonstration purposes. And supernatant is formed. And one can see the particles form loose aggregate, they're flocculating. Extremely important for pharmaceutical purposes is sedimentation and dispersibility. So pharmaceutical products needs to be redispersible if they are flocculated and show sedimentation. And this is clearly labeled. Pharmaceutical formulation is to provide uniformity of dose upon redispersion. That means it has to be readily dispersible. Preformulation suspension will be prepared. Variety of suspending agents. 100 milliliter graduate cylinder is rotated 180 degrees or 360 degrees at 20 RPM, and number of shakes are measured that free of sediments. And uniformity of suspended drug is measured at different time intervals. In this case, zinc oxide suspension reached dispersibility shown in three different suspending agents: sodium CMC, acacia, and allobarbendis, a natural suspending agent. The concentration of suspending agents 1, 2, and 4% are used, and the number of shakes are measured to see the redispersion. As it can be seen, as concentration increases in each of the cases, number of shakes required increases to completely redisperse the product. In addition, the graph shows the sedimentation rate of zinc oxide. This type of information, sedimentation rate and redispersibility, is provided so that selection of suspending agents can be done appropriately. Most of the suspending agents are rheology modifier. Commonly used suspending agents are colloidal system, magnesium aluminum silicates used with gums such as xanthan gums. Cellulosic thickeners are also used, and they come in of grades and viscosity. Polymer thickeners such as acrylates, carbomer, they work at low levels and they are sensitive to salt contents and therefore affects rheology. Higher level of rheology modifiers do not necessarily provide better suspending agents. Here, different suspending agents are shown. At level in water, carbomer produces gel-like structure. Gel maker powder also produces thick gel structure, and they are not good suspending agent at that concentration. Xanthan gum, as you can see, has a fluidic property at 0.5%. Many acrylate polymers are used and showing good fluid property. These type of studies will be done in preformulation, different suspending agents and their rheological properties. Flocculation is an acceptable way of making a product. Flocculation modifiers are used. Solid are suspended in vehicle and they form loose floc through bridging or agglomeration. Mechanism involves zeta potential to low value of around 0 to minus 5 millivolt in it neutralizing the charge on the particle that will reduce the repelling of the particles or bridging between the particles by polymer. Shown in this diagram is polysaccharide and kaolin. Kaolin particles are suspended. Particles have slightly negative charge. Polysaccharide has flocculation functional groups, as shown here, green Y. When kaolin is suspended, the flocculation functional group will be attracted towards particle and will form loose agglomerate. The degree of flocculation beta is a parameter to determine flocculation. It is provided by the equation sedimentation volume of the flocculated suspension divided by sedimentation volume of the deflocculated suspension. We measure VU or VO for flocculated suspension and divide that VU or VO for the deflocculated suspension. When beta has a minimum possible value of 1, there is no flocculation, and entire suspension is deflocculated. Suspending agent also can affect dissolution and therefore bioavailability. So this type of study will be done in a preformulation. In this case, tindazole, different suspending agents, concentration is shown here, and the dissolution is measured in zero point 0.1 normal HCl at 37 degrees. Sodium CMC, 0.5 to 1%. Dissolution changes. This is the dissolution blue dots here of the neat drug, xanthan gum, and the effects on dissolution. Sodium alginate, the higher level of sodium alginate, 2%, shows plateauing of the dissolution. This type of information on dissolution and the effect of concentration of different surfactant will be provided to the scientist. So formulation scientist has information on particle size, palatability, suspendability, flocculation, and effect of suspending agents and their concentration on dissolution of the drug. This type of information comes out of the preformulation. Then it is provided to scientists so that scientists can then select the composition and processes at laboratory scale and then eventually use that for commercial scale.